So the fourth and the final conference of the day is Solar Thermal Process Heating in India, Opportunities and Benefits. For the same, I would like to invite on stage first our chairperson, Mr. Jaideep, Malaviya, Secretary General, Solar Thermal Federation of India. Then we have Mr. Aravindh, Scientist for B Solar Thermal Division India. Mr. Aravindh. We have Mr. Rene van Berkel, India Representative, UNIDO. We have Mr. Niranjan Desai, Vice President, Business Development, Orb Energy India. And last but not the least, Mr. Madhusadhan Rao, Managing Director, Oorja Energy India. I would request Chairperson Mr. Jaideep Malaviya to now convene the session. You can do it from there as well, sir.
I think there's a small change of schedule, so they say that I should chair, so I will do that. I'm Rene van Berkel, I'm the head of UNIDO here, the representative of the regional office. And this session is about solar process heating. And actually I also had the first presentation. They always taught me that you should not be the presenter and the moderator in the same session, but I've just been catapulted into that. So nobody can keep me to the time, that's the advantage, so that's easy. So I will move there and talk a little bit first. So good afternoon. I would like to talk then on the bit of the background for the solar thermal, and that's in specific to process applications, because I do represent UNIDO, United Nations Industrial Development Organization. I wanted to come back to what is in the Constitution, that it's the duty of every citizen of India protect and improve the natural environment, forests, lakes, rivers and wildlife, and compassion for living creatures. So the right to a clean environment is basically ingrained into the Constitution of India. As I mentioned, I represent UNIDO. UNIDO is the specialized agency in the UN that deals with inclusive and sustainable industrial development. So we have been working in India since 1966 on meeting the development goals by furthering industrial development, creating employment and overcome poverty, help to produce goods and services that can be traded. And then we just last year completed our country program, which was focused on green industrial development, where we have projects on energy efficiency, renewable energy, and environmentally sound management of waste and chemicals and clean tech incubation. And then inclusive economic development, where we work on issues like manufacturing excellence, lean manufacturing and related issues. And we also engaged in projects which transfer knowledge and technology from India to other developing countries. We're just finalizing our country programming framework for 2018-2022, as a typo here, which is dealing with productive and resilient MSMEs, so productive capacities of small businesses and solutions for climate, resource and environment. That's where solar thermal fits in, responsibility and inclusiveness of value chains, and also policy for industrial transformation. I will not talk too much on that, but would be happy to discuss further after this session. So I want to come basically to the industrial process heat and take India's perspective. So industrial energy consumption is responsible for about 1/3, 32% of India's total energy consumption. And if you then go around, you see that out of this 32%, basically 3/4, 74% is thermal energy, which is heat, and only 26% is electricity. So there's a huge window of looking at heat directly rather than going for electricity. If you then look at the temperature gradients, it's common to kind of differentiate between low and medium and high temperatures. And I think that we are mainly focusing then on the low temperature heat, which is 30%, and the medium temperature heat, 52%. So medium temperature goes up to roughly 400 degrees centigrade, and that is 52% of the energy. Of course, we have then the high temperature heat, which is used in power generation and for melting metals and glass. Of course, that is not immediately within reach of solar heating. And of course, the sector is highly dependent then on imported crude, which is used for these thermal applications below 250 centigrade. So solar technologies can produce quite conveniently the heat in the range of 50 to 400 degrees with different systems, and that can then be used in different thermal applications. So why would we do that? Of course, the energy demand from fossil fuels can be reduced, the tons of coal that can be reduced, the import duties that are there, and ultimately also reductions of the greenhouse gases which are contributing to climate change. So if we see here this diagram which shows you the solar energy utilization, of course there are the two routes basically, the solar photovoltaic PV, which converts solar radiation into electricity, and that's basically as a drop-in solution. Once you have electricity, you can use it for anything, for your air conditioning, for your computers, for your LEDs, for anything basically. The other option is then to go solar thermal, and then we produce heat. And this heat can then be applied in process heating applications or cooling applications, or hot water or steam. So we are particularly focused, if we talk about industrial applications, on the concentrating solar thermal technologies, which are basically use mirrors and lenses to produce low to medium temperature heat for various applications. So it's not the the smaller home scale systems where we just have a collector and produce 50 or 60 degrees water for a shower or for other applications, but really looking at higher temperatures where we can do pasteurization or dyeing of textiles or evaporation of water. What is then the key is that these devices will then normally need some element of tracking, so to have increase the efficiency. There is normally an easy integration of the CSTs, the concentrated solar thermal, with existing systems. So as you see here, there is the hot water or steam provided to a preheating boiler, and then to a boiler to produce higher quality steam, or also the preheated water can be used directly for applications where we need only water of heat of 200 or 300 degrees. And then the water is recycled back to be heated in the solar thermal system. These are some examples to give you a sense of what is possible. So this is example on the milk pasteurization, 338 square meters. This is process heating for pharmaceutical, process heating, heating for metal processing. This is for this is also process heating, and then this is for process heating as well. So 800 square meter. You see then also the different technologies, the solar trough, and then here you have the dishes that are using different ways to basically concentrate the solar energy so that we can get higher temperatures. There has been quite significant growth of the CST projects in India, if we see it here, particularly in the recent years. Oh, sorry, that went too quick. We are currently standing at the end of 2016 at about 18,000 square meters of collector area, and the 271 installed projects with a capacity of 52 megawatts. This is then complementary. I will not focus on this, but the capacity installed in the solar water heating systems is of course much larger. We talk already about 11 million square meters of smaller installations, mostly at housing level, at the individual dwellings, or for hotels and restaurants and hospitals in some cases, so in the service sector. In the work that UNIDO has been doing, we have been trying to come up with zooming in on the sectors where CST deployment is most promising from the perspective of the application of the heat, but also investments and so on. And they came up with the 14 sectors which are there, and they're quite broad. Even in these sectors there are different applications of textiles, pharmaceuticals, tobacco, breweries, pulp and paper, electroplating, food processing, rubber, chemicals, petroleum refineries, desalinations, even ceramics in some applications, and steel, and other tertiary industries. I mean, the time is not really there to elaborate on each of these opportunities, but we're working on different technology packages that showcase how this, the concentrating solar thermal can be incorporated in these industries. You see that currently this concentrated solar thermal has been very much focused on the community cooking, so large cooking facilities, and some process heat and cooling, and then some laundry applications. I wanted to say a few words on the kind of financial incentives that are available, because there is certainly incentives available to facilitate the implementation there. So there's central financial assistance, which is a capital subsidy through Ministry of MNRE. Then there is an opportunity for subsidized loans through IREDA, the India Renewable Energy Development Authority, which is under the GEF supported project from UNIDO. And then there is also the opportunity for tax benefits due to the 80% accelerated depreciation. So it's a bit difficult to put exact figures on how much a payback is, but if you're substituting furnace oil, diesel, or pipe natural gas, the payback time is in the range of 3 to 4 years. Coal, biomass, wood, then the payback time would be 5 to 7 years. Cooling, it's still longer time frame, 7 to 10 years, but also there the payback times are coming back. And this gives you then a sort of indication of how much the energy savings are. So if you have 100 square meters of dish, saves about 20 tons of coal, or 5 to 10,000 kilograms of LPG a year, or you see the equivalence of wood. So it's quite significant what can be achieved. So I want to say maybe a few things on the role of UNIDO in promoting the CST. So the project that UNIDO is running with support from the GEF, the Global Environment Facility, and implemented with the Ministry of New and Renewable Energies, is really trying to help to find specific applications of concentrated solar thermal, and then also looking at how this can be standardized, the utilization. So I think the main difference between the PV system is that you can just install it and you have electricity, you can do everything with it. Process heat, you will have to do a system integration and figure out where to best utilize the heat that you generate or the steam that you generate. And the UNIDO work complements then the support program to help remove the barriers also related to the production of CST technologies. And we have a few of the producers here that can talk more on this, that of course we can bring the cost down by doing more domestic manufacturing and fabrication. The financial arrangements on the UNIDO project is summarized here, but we can elaborate on this more. The project's developers contribution would be in approximately 25%, subsidy of 30% by ministry, and then a bridge loan that could be done against normal interest rates, and then there's a loan for the remaining amount that would be provided at an interest subvention, with the interest subvention paid out of the Global Environment Facility. In this manner, basically 75% of the project cost could be considered an upfront for the provision of the loan, including the bridge loan, and then a short period for completion. The installation is also quite a short period of time. So this can then, all you see, there's different elements that come together in the financial package, and the beauty of it is that now IREDA has agreed that it will serve as a single window, so to speak, to accept the applications and then assist with obtaining the financial support. I maybe wanted to say a few words on this maybe somewhat complicated diagram, but basically we see, if you go here on the bottom, you see that there is about 200 gigawatt thermal needed for process heat in the low to medium heat category, and then we can look at how much of that could be provided by it, looking at what's then the equivalent energy input from concentrated solar thermal. And we have to look, of course, for the sunny hours, then the process mapping and the solar thermal potential, and then some technical and market potential. But already in the current situation, that gives us a capacity of or a market potential of about 6.5 gigawatt thermal energy. I mean, the current, this compares to a current target of reaching by 2022, if I'm correct, 200 megawatts. So compare from 200 megawatt to 6.5 gigawatt, there is still a tremendous leapfrog. And even to achieve the 200 megawatt, we have 50 megawatt installed right now. So we talk about potentially fourfold increase in the next 3 to 4 years, and then potential for 100 times more after that. So the market potential 6.45. So I would like to conclude here and then also leave it up to the other panelists to talk more on the specific technical details. But basically the National Solar Mission has quite a number of policies and schemes and targets in place now, and government is really bound to set for time-bound achievement. So government is really looking at this. Suitable solar technologies are available for process heat applications from low to mid temperature range up to 400 degrees. You might say that's relatively cool, but it's 50% of the, or 52% of the process heat being used. So if you can make a dent into this 50%, it is quite significant. They have already proven technological maturity, financial viability in few industrial sectors, but the penetration in other sectors is still more action needed, and that's what we're trying to do. I think that it's a win-win situation for users, as it then saves, of course, on the fossil fuels and makes greening by reducing the carbon footprint, which is of interest. So I would like to conclude here. Thank you very much for your attention, and then I will change my hat and become facilitator again. Thank you.
Thank you. I will continue then from this side. I think we will then go MRE first, government first. Mr. Aravindh, may I ask you to address us and talk about the MNRE role on solar thermal?
I think he'll be always having a trouble seeing me from here. Apologies. First, for me it is like getting a same topic, when a teacher gives the same topic to the entire class, and you need to give a different presentation altogether. But it's quite hard because our chair has given all the details which are quite common. No, it's fine. Quite the same. So I'll be sticking to only 2 slides. Which will be much more from the ministry side. So the ministry has been implementing this scheme for the off-grid and decentralized solar thermal application scheme. And so far, under the ministry's support, we have achieved about 234 projects with a cumulative installation size of around 60,000 square meters, which is roughly translated to around 40 megawatt. So we can, in the application wise, we can see that around 47% of these installations has been done in cooking application. And in process heat, it goes to around 35%. And for air conditioning, it's 15%. And for other applications, it goes to 4%. When technology-wise, we could see the Scheffler dishes accounts to about 50% of these installations, where parabolic trough will take 8 of that, and parabolic dishes will go with 14%, and other technologies like Fresnel lenses, parabolic, iron dishes will go for 10% of this thing. And as we could say that we have many applications done, and we could the ministry has identified through UNIDO as well as other agencies which are dealing with us, and we found like around many industries where the technology can be used, then applications ranging from cooking, process heating, air conditioning, milk pasteurization, cooling, space heating, all these things. And basically the ministry, the earlier scheme which the ministry was implementing ended up in 2017 March, and it was extended till 2017 for the completion of the lot projects. And the ministry was in the process of reviewing the scheme, so that we should see that the scheme is going to help someone in the country in some way or the other. So the reviewing was done, and the new scheme for the CST, named the Off-Grid and Decentralized Solar Thermal Technology Scheme for community cooking, process heating, solar applications in industrial, institutional, and commercial establishments, was launched in February 2018. And based on this, we have set up benchmark cost for different technologies. We have categorized 5 technologies for supporting by the ministry. What we have is dish types cooker. We earlier had a separate scheme for that, but the acceptance for the scheme among the public was become duller. So as to have to continue the support and not to dying out the scheme, we kept it in this scheme, and we have made the benchmark cost for 7,000 per square meter. And then solar for direct heating applications and drying, non-imaging and compound parabolic concentrators with 12,000 rupees per square meter, and single axis systems with Scheffler dishes including, which was holding up the major part of the share in the earlier scheme. We have hold it for 15,000 square meter. And next, single axis systems with solar grade mirrors and evacuated tube collectors, so as to maintain the quality of the systems being provided to the customers. Yes. We maintained the system at 18,000 square meter, 18,000 rupees per square meter. And of course, the double axis system, which are more effective and have better efficiencies, we kept it for rupees 20,000 per square meter. And the MNRE support will be given at 30% of the benchmark cost, or otherwise the expenditure incurred in the project, and 60% for non-profit making bodies like institutions, education institutions, hospitals, etc. At 60% for special category states like northeastern states, Jammu and Kashmir, Himachal Pradesh, Uttarakhand. And of course, MNRE is also having a program with partnering with UNIDO, which provides a loanware subsidy, which already the chair has already explained in his presentation. And I close my presentation, and I think I'll be the person who will be getting a lot many questions after the section. Thank you.
Thank you very much for elaborating on the new support package that was just recently announced, and I think it's very encouraging that the government is taking the lead to try to continue the support of these new technologies. So I think that we then first go to the two companies, and then I'll ask the Federation, the business sector, to speak as the last. So maybe I can ask Mr. Rao, as Managing Director of Oorja Energy, to speak first, and then I go to you after that. Yes.
So all those numbers are good, but I'm going to talk about where the rubber hits the road, right? We're going to specifically talk about a particular case study for an automotive major. It's one application so that everybody can understand how this is actually used, what technologies are available, and how technology choice depends on what is the application. So this particular application that case study we are going to talk about is for Tata Motors, and this was implemented in Jamshedpur. Before that, just a couple of slides about what we do as a company. Oorja is a clean tech heating and cooling company. Everything we do is about heating or cooling. Either we use a renewable source like solar, or operate it, whatever process is there, whether it's cooling or heating, in a more energy efficient fashion. So we have multiple solutions around that. We're going to talk about one of them. In solar heating, we have overall 4 products. Parabolic trough concentrator, we have what are called CPC, which are milder in concentration. We are going to focus the attention on the CPC in this particular presentation. But if you have questions about the other technologies, we can discuss that later. We also have done a project using heliostats, and then there is sludge or waste treatment using solar that we also provide. Okay. So let me dive into the case study. This project was implemented for Tata Motors for drivelines division. Just so that you understand what is a driveline, it is nothing but the mechanism that drives your vehicle, right? So axles and transmissions. So if you see this, there are a lot of parts, and this is what is assembled in that division. So if you see, there are a lot of parts which need to be assembled, and most of these are parts which are casted. So when you cast it, they come with burrs and all that is cleaned. They are deburred, sometimes sand sanded, but even when they arrive from their suppliers, they still have a lot of dust and all that. So these parts are actually cleaned, and to clean them, they have a washing machine, just like something like ours, but you know, yay big. And these parts are put in this and washed at about 70 to 90 degrees centigrade. As of now, this particular washing machine, just like our washing machine, has an electrical heater or a bank of electrical heaters. If you see the bottom part of it, which is protruding out a little bit, that is the container where, or the small tank where water is there and there are electrical heaters in that. The job of electrical heaters is just to keep the water at somewhere between 70 to 90. There is a thermostat that keeps cutting in, cutting off, depending on the usage of machine. So this particular plant has 48 such machines. We have implemented pilot for just one such machine. Okay. So when we first started talking to Tata Motors, when somebody talks about concentrated solar, everybody imagines it to be, you know, a big solar concentrator, something like this. It looks good, you know, has movement and looks good to show to the, you know, prospective customers and all. But even though we manufacture this, we were not very comfortable suggesting this. Customer wanted this particular product, and we also have a smaller version of this. But what we suggested was something that is more appropriate to them, which doesn't consume their ground space, because ground space is expensive. So we suggested what's called a compound parabolic collector. This is a solar collector that is similar to your evacuated tube collector, if you've seen those, which are used primarily for domestic heat applications, in some case commercial also. A speaker after me will probably speak more about those. The difference is behind these vacuum tubes, there is a compound parabola, an aluminum parabola, if you can see the visual, where solar radiation that's falling on it is concentrated or redirected to this evacuated tube, because of which you can get higher temperatures than what you can get from the regular solar water heaters. So this product is appropriate if your hot water, not steam, hot water requirements are up to 120 degrees centigrade maximum. Okay. Wouldn't recommend this for steam production or any other applications. Okay. I'll explain the product in a little more detail. What we have two versions in this that are available. What we suggested to Tata Motors was a heat pipe heat pipe model. The advantage with heat pipe model is that if you see on your top right, okay, where is the pointer? Can I point? Yeah, there. So if you see, the process water would only come in and go out in the header manifold. It doesn't get into the water tube, evacuated tube. The advantage with this is that even if your tube breaks at some point, you don't know with plants what happens. There are sometimes monkey manons and all these things. You still don't have your process water coming out of it. Okay. Second is your pump pressure is much lower because you don't have water going inside something. It's traversing a lot less path. Okay. Other reason for suggesting a compound parabolic collector, a CPC, instead of a parabolic trough collector, because it's a low temperature one, is a CPC can use diffuse radiation too, which a concentrator like what I showed earlier, PTC, cannot use. So there's an inherent, I wouldn't call it efficiency, the input, there's reduction in input when we use a concentrator like a parabolic trough collector, whereas here my input goes up. So if you see in the months of June, July, when there is monsoon, okay, we do get a decent amount of output with this product, whereas with a parabolic trough collector, it would be difficult to get output. It is lightweight, doesn't need ground space. So the schema we gave, this is the schema. This is the actual picture from the actual installation. These have been put on the roof, consuming no ground space, okay? And a pump is used, and it is heated indirectly. There is a heat exchanger here, which the solar heat is given to this tank. It's a 1 cubic meter tank, and it is used as storage. The water from this is the existing washing machine. There have been no changes done to the existing washing machine. Okay. This is the biggest issue that we face when we try to put something new in a process. The process person, the head of the process, the person who's in charge of the process, doesn't want any changes to the process, because ultimately the company earns money from producing something through that process. So nobody wants to disturb that process. So the key here is not actually selling the product here, but how do you engineer the solution that, one, to implement it and also to run it. There is hardly any downtime to the customer. And so that's why we didn't disturb anything. We just took 2 tappings from the tank that I showed you, and there's a small pump which takes heat from this. Okay. And if the heat from this tank is not enough, the backup of electrical heater kicks in anyway. Okay. So whatever comes, whatever heat is provided by the solar is taken, and if that is not sufficient, the backup kicks in. Okay. And of course, there is a control panel which is all automated. One of the things that I keep saying and I keep seeing from the customers is, customers want something that is red button and a green button. That's what they want their operators to do. Morning, 9 o'clock come, hari batti dabao, 5 o'clock, 6 o'clock, when it's over, lal batti. And as manufacturers, as solution providers, we have to provide those. Otherwise, I mean, that is the reason why I feel some of the installations in CST have not been working, because it's too much of work. So as manufacturers, if we try to take out that work from our customers, I think there will be more successful installations we'll see in this technology. Just a little bit more close-up of how this works. As I said, oops, let me go back. This is the only place where the application as water or the fluid flows in. It doesn't come into these tubes. That's a reflective mirror sheet which is behind that. And just a little bit about how a heat pipe technology works. In the vacuum tube, you have a copper pipe in which there's a fluid, a low boiling point fluid. When it gets heat, it goes up as vapor. Heat is exchanged. Maybe this is a better visual. The cold water, when it is coming, heat is exchanged. Let's call this condenser, because this is where the vapor condenses and goes out as hot fluid. In this all process, if you see, if anything were to happen to the tube or the pipe, any damage, nothing happens, no interruption to your process. Okay. The other model also is available, where the copper is as a U inside it, but more copper. And one advantage this gives us in some places is it allows us to do a drain back of the system. And why is drain back important? Let's say the plant is not running on a Sunday. Okay. Then if I let water be in the system, then there are chances of the water becoming steam, and then of course there are safety valves, but long term that could damage the system, unnecessary pressure building in the system. But with this, when there is a U pipe, you cannot drain it completely. Okay? So with a heat pipe, because the water is just in the header, you can drain it, and that way you are able to take care of the days where it is Gandhi Jayanti, Sunday, or whatever it is, when system is not working. Water need not be there when it is really hot summer out there. System shouldn't be producing steam. It is not designed for that, even though there are safety safety valves in that. Okay. Let me skip that. This is just how we install it. This is the actual installation. One of the things that the customer gave us feedback was it is not easy to clean this, okay, because there are tubes and there's a curved surface. So what we did was we developed a new product which would be supplying to another customer. So we came up with a product that has a flat glass on it with a frame. Okay. This is much easier to clean, and we now also have a system, a waterless automated robotic cleaning system which does not require water, has its own, doesn't require power, has its own solar PV and battery. Morning it wakes up, sees if there is radiation, just goes and cleans it and comes back, it's in its position. Okay. So this is again us taking feedback from the customers saying, you know, every week we have to send people up there onto the roof, clean it, and you know, the EHS department is raising, the safety department is raising concerns. So then that's when we developed this product. For most customers, we operate both, offer both options depending on what they really want. If it's a ground installation, it's easier to clean. Okay. So anyway, more about the particular installation. It is 110 square meters of solar concentrators up on the roof, total 25 units. Okay. At peak, this can generate 65 kilowatt, on an average about 45 kilowatt. This is the calculation, if somebody's keen on it. So there is a controller we have given so that it's, as I said, yeah, I don't see a green button, there are only red buttons there. So that somebody can just come, switch it on, switch it off. So the control logic is very simple. If the tank temperature, our logic is if the tank temperature is above 80 degrees, then the pump switches on and takes heat from the tank in which we are dumping all the heat from the solar concentrator. If it is not, the pump doesn't operate and the electrical heaters will kick in on their own. The second is the solar system doesn't operate unless there is the certain amount of radiation. So we have put pyronometers there, and unless the radiation is above 150 watts per square meter, the solar system doesn't kick in to provide the heat. So this automation has been done, and every day, I mean, the system comes on its own and works on its own. Here's some of the data from the installation. This is February. I chose February because the radiation is typically low. Even at low radiation, you will see that the temperatures are between above 90. This is a little more enhanced view of the temperatures that we are achieving at the site. Last slide. This is a quick payback calculation of the installation. The net investment, courtesy MNRE for subsidy and UNDP from the earlier program. The total payback is about 2.8 years, which saves about 1 lakh of kilowatt hour electric, sorry, that's kilowatt hours, and a CO2 savings of about 100 tons. Okay. So that's about it, I guess. Thank you.
Thank you very much. That's a very interesting case study, and it shows actually how you can easily incorporate it, certainly at the level of hot water. So just switch on and off once the water is there, and that can be automated. So that's very much. Thank you very much for that presentation. I think we go to the second industry presentation. So I'll ask Mr. Niranjan Desai, isn't it? Orb Energy. Yes, please. Floor is yours.
Good afternoon. I am Niranjan Desai from Orb Energy, from Bangalore. I don't have many slides to present. I just brief you on the company's activities as so far, and then few slides which we have done for Unilever. You might have heard Unilever is FMCG global company. We have done a couple of projects for them, and I've just give you a glimpse of what we have done there. We started in the year 2006. We are a 12 years old company. We have got 2 plants. One is making PV modules, and the other is making the water heating systems. PV module is a 60 megawatt plant, and we have a workforce of about 300 people working together. Then we have, this is one of the PV installations that been projected here. A couple of them for commercial as well as for industries. The second one is industrial water heating system using evacuated tubes. You heard Mr. Madhusadhan Rao using a technology of CPC and the heat pipe. I have not used it so far, but I have tried to do it with the existing technologies like the flat plate and the ETC. Yeah, there are some challenges because, as you rightly said, in case of open loop ETC system, the water directly goes to the tube, and if there is a temperature rise, there is a very possibility that the tubes break. Yeah, that you have to mitigate somehow. And there are some residential projects which are done, which is actually the major turnover that we are getting from the residential segment. Similarly, the water heating systems also. Yeah, this is where the main presentation of mine starts. This is a 3 gigajoule solar water heating system installed for one of the Unilever projects, and that too, it is not in India, it is in Kenya. Somehow we got the interest shown by this particular plant, which is actually doing a blue band product, like the toothpaste, surf, all those popular brands that you see in India is manufactured by Unilever, Kenya and elsewhere also. They have got about 137 factories all over the world. When this inquiry came to me, it was a challenge because the requirement was very huge. They had a 4-ton boiler and even a 11-ton boiler. Sometimes they have to run that when the product quantity required is more, then they have to run 3 shifts, then they will use the 11-ton boiler. So they were aware of the boiler feed application. So, and I also explained to them the difficulties in giving a boiler feed application. You know, the flat plate technology that I am trying to, recommend them cannot give me steam. It can give me only water up to maximum about 85 to 90 degrees. If I recommend them a boiler feed, I have a problem there. The problem is, steam has two types of heat energies. One is the sensible heat, another is the latent heat. And 1 kg of steam will have about 650 kgs of kilocalories of energy. Out of 650, about 180 is the sensible heat and the balance about 480 is the latent heat. So, giving latent heat is not possible, so I end up giving only the sensible heat. So the sensible heat also not to the extent of 180 kilocalories because the temperature rise cannot be more than 90 degrees as I told you. So I am talking about 90 kilocalories of energy being compensated here, which is about 15% of the total energy of 650. Obviously, the maintenance guy of the plant will say, after installing this system, if I save only 15%, why to go through all these hassles of maintaining the system? I knew that. These are the questions which will be asked. So then I recommended, let me see where you use steam to generate hot water. And I recommend you flat plate technology to that, where you are using about 90 degrees centigrade water, and I can give you 100% saving for 6 hours in a day. They asked me, how you are going to do that? I said, look, if you have got a steam being used for hot water generation, definitely you will have a tank. So they had a 10 KL tank which is used presently, passing steam through that through a calorifier, we call it as a calorifier, generating hot water, and using that hot water into some other processes. So then I said, this is the best application that I can look for. Then I asked them several basic questions. What do you think is the steam consumption for this process? Say they said about 120 kgs per hour. Then I calculated my own, I made my own calculations, 120 into 6 hours, 8 hours, so much of energy, and this much of energy is used to heat the water. So if I can provide this energy through what flat plate technology, then we are done with it. So I went into that kind of a calculation and that kind of a application, and I suggested them the same system can be replaced with 170 collectors, and I can save 100% for that process for 8 hours. You can switch off the steam inlet to the calorifier till 6 o'clock, right from 8 o'clock in the morning. And as long as the sun energy is available, your hot water can get heated up to 70 degrees or 80 degrees. They wanted about 80, 85 degrees, but actually in practice, they were only using about 70 degrees. So this is how I designed it and installed the system here in Nairobi. This is presently running now for the last 1.5 years now. So the estimated savings that is expected out of this is about 8,600 gallons of HFO, heavy fuel oil, which is the boiler fuel. And another important, or I can say a unique system I integrated with this is the remote monitoring system. You see, when you say that you are saving so much, people don't believe it unless I show it. So we devised a methodology where you can measure the kilocalories of energy saved, and to tell them that exactly about 3 gigajoules per hour per day is being saved. So we devised a controller with the SIM card and all that, so you can remotely see that on your computer as how much energy is being saved every day. I could have showed that it's on my laptop, but there is for this particular thing we already installed it, but it's not commissioned. But in another case, in India, we have done it already, and I can show it also online. And in fact, in my house, for my residential purpose, I installed it, and it's working fine. Every day I get how many kilowatts of energy I am saving. So in fact, after this installation, people visited from our company, our CEO and all MDs and all, they visited, and their reaction to this particular thing is, we are even saving more than what is recommended, supposed to be saved. So I was really thrilled, I was wondering whether my calculation has gone right or wrong. But that particular feedback was really overwhelming for me. Followed to this is the next installation we got into from same Unilever factory from Myanmar, that is in Burma. Here, slightly there was a difference in the application. They were not using steam boiler here, they were using hot water generator. If you recall, hot water generator and steam boilers are two different things. Okay? And using hot water, generating hot water for using steam is actually colossal waste, because you are taking the water into steam, into vapor, and again converting that into hot water. Instead of that, if you use hot water generator itself, like all the hotels will do for bathing application, you can save a lot of energy. But people go in for steam for different reasons, because there will be different applications in the factory. One particular application may require about 170 degrees, another application may require about 70 degrees. That can be done only through steam boiler. It cannot be done through the hot water generator. But in this particular place, for them there is only one application of hot water, that is for cleaning the process. So that was the application. So we went ahead with the Again, the same calculation I did here also. Like how I asked them, how many kgs of steam per hour you are using? My question here was, how many liters of diesel you are consuming for this boiler per day?
It works.
Okay. You want me to go through fast?
Yes, yeah.
So this is again 600 gallons of diesel you are saving from this, and then similar, and we have provided automatic switchover from solar to a hot water generator, so that as Madhusadhan said, without the hassles, people can simply press the button and it will go on automatically. And again here we use the existing tank. So that has been my core expertise, I would say, because I don't recommend a tank to them as to the cost, as to the higher payback. So we use that tank and integrate the system with them, with the existing tank. This is another application which I told you in Bidar we had done that, in Karnataka. This is again for a paper industry, but this is for the boiler feed. I also explained to him that this is what is the percentage of saving, but he was very much interested in that. So we went ahead and he said 15% also is good enough. So we went ahead and did that. Okay, this is what my presentation so far.
Thank you very much. That's very interesting to see the different application, and indeed also showing that figuring out where to use the heat is then, of course, part of the making it economically viable. So thank you very much for that overview. So then I would ask our last speaker for the session, Mr. Malaviya, as the president of the Solar Thermal Federation of India, to speak a bit more on the general industry issues. Yes? Thank you.
Thank you, Chairperson. Good evening to you all. Good evening. Yeah, I can understand. This is the last presentation of the day, and it's testing time of the patience. That just reminds me, I faced a similar situation. Just something on the lighter side, very quickly I'll do. I am a Rotarian. How many of you know there's a Rotary institution? And this is a practical incident that happened. So I was the assistant governor. My governor couldn't come that day, so I had to substitute him. And usually it's the governor who's the chief guest. He has the last presentation to make. So a child kept on coming to me right since the first presentation was happening. That, "Uncle, when will be your presentation be? When will be your presentation be?" And that lasted almost for 2 hours. He must have come 10 times. And I was wondering, what's the curiosity in this child to come so frequently? Because Rotary as an organization is more for the adults or the elders. Then I asked him, "Child, why are you so curious about it?" He said, "I read in the agenda, after your presentation is the lunch." So, please bear with me. I'll try to be as soon as possible. I know we have short the time. I am Jaideep Malaviya, Secretary General, Solar Thermal Federation of India, and I'll be speaking to the point right on the topic of the subject of solar payback, because our previous speakers have already explained to you about what the solar industrial process heat has to offer. We had some interesting case studies, and also about the technologies, the central government programs and the ministry programs, and of course the excellent work being done under the UNIDO. So let's thank them. Now, one of the fastest growing process heat countries, India is placed amongst the top 10. Matter of pride. A survey undertaken by the Global Solar Thermal Council places India as the 5th fastest growing solar process heat market and the only one in Asia. Feel proud? Always, we have our neighbors always compared. So somewhere here we have scored over them. We have an edge. घर जाके थोड़ा कॉलर ये कर देना, don't worry. We are the 4th largest as far as the solar collector market, meaning the solar water heater. So I'll just skip this. And we continue to be amongst the top 10, but of course, the solar water heater market is slightly on the decline. For reasons you know, you need not be. The industrial process heat overview. Medium high temperature solar thermal program is operative since 2 decades, but is paltry as compared to the solar collectors. If it actually compare apples to apple in terms of the achieved area, it's a very minuscule. I think Mr. Aravindh made a mention about little over 60,000 square meters. As far as the solar water heaters are concerned, we have already crossed 12 lakh square meters, 1.2 million. All right, okay. The industrial sector consumes about 38% of the total energy consumed in India and offers hope for conserving up to 25% using the renewables. 15 million tons of fuel oil per year for heat up to 250 degrees centigrade alone in industries, and up to 5,000 electrical units used for heating. It's a gigantic requirement. About 17,500 megawatt of power generated through diesel generator sets for cooling as well as refrigeration, and where there is shortage of power. India has good DNI in several places, not all. We are not that big or a great DNI country if compared, but certain areas do receive good, and solar thermal systems that work at efficiencies between 50% to 70%. Now, the basic idea behind solar industrial process heat is to reduce the burden on the foreign exchange of importing the fuel oil. Hence, there is a need to accelerate the growth of process heat in industries and commercial establishments by removing barriers and develop market through required measures. Now, I'll correct, because what we had the last figures were that the achievements are close to 53,000, but it has crossed 60,000 square meters. As I said, amongst the top 5 countries, 22 manufacturers making 6 types of different collectors for the concentrated. We have one of them here. Now, the only country in the world with highest steam cooking systems. This is another area of pride. We have showcased. In fact, it's acting as a role model now globally, particularly in the International Solar Alliance countries. Some of you must be aware about the International Solar Alliance. So we have set the ball rolling. We have set a trend. Only country with wide applications for high temperature solar heat, that is the process heat. Meaning, we have showcased by way of the UNDP and the UNIDO programs that industrial solar process heat has wide applications, whether they are for the food processing, for the dairy, for the textiles, for the metal processing, and so on. I'll skip the other things. Now, the industrial process heat overview vis-a-vis the direct normal incidence we have. This study was undertaken by Solar Thermal Federation of India. Now, solar process heat we shortly refer to as SHIP. SHIP stands for Solar Heat for Industrial Process. So, in my future talks, I would be only referring to SHIP, S-H-I-P. So, if we see the western region, particularly parts of Gujarat, Rajasthan and the western Madhya Pradesh, they offer one of the best DNIs and where industrial process heat can pay back faster. This is based on a study undertaken. Now, which are the industries that need process heat up to 300 degrees? Food processing, breweries, rubber, pulp and paper, tobacco, electroplating, pharmaceuticals, steel re-rolling, then textiles, chemicals and fertilizers, refining. I think all these are even presented in the first slide that Mr. Rene Berkel had, and in fact, they have identified a huge capacity. Now, when STFI about 3 years back had undertaken a survey, these were the results, which were the industries identified. And these were based on the feedback received from the stakeholders, from the developers and the manufacturers. The highest was in the food processing. Dairy was the next, then textiles, and the engineering, which included the metal processing, and then the pharmaceuticals. And then there are host of other applications or the end use where hot water requirement up to 150 degrees is desired. So, what the study concluded was that achieving 10,000 square meters annually and even up to 25,000 square meters, if right policy framework exists, can be achieved. So that's the potential. Maybe somebody few months back said that even 100,000 square meters or 1 lakh square meter can be achieved. That's the potential we hold. Now I'll skip this about the temperature requirements. These are the various technologies they were already told. Now, what our study said was the best ideas to accelerate market. Create demand worth 100,000 square meters in 3 years through tenders in large-scale public sector undertakings and identified potential industries. Now, as an industry body, we have been, for the past 3 years, recommending to the government to come out with some kind of an obligation. See, why the solar photovoltaic industry grew? The renewable purchase obligation was the driver as a part of the Electricity Act, which mandated the electrical utilities to either generate or trade certain percentage of renewable power. And this figure will grow with time. So it started with 0.25% and finally would be at 20%. If a similar obligation is brought through amongst those industries that are high consuming heat, I am sure the market would accelerate, and I am confident even the manufacturers would agree to that. Encourage the energy service company model as it ensures proper life cycle operation. Mandatory standards to be implemented on priority. Subsidy be linked to the performance rather than the area. So, if there are claims against a certain DNI, this is what it will deliver. Incentivize rather than going flatly on the area, because you know different technologies offer different output. So why should there be a fixed subsidy per area? A special mention about solar thermal in the Perform Achieve Trade, which is a scheme operated under the Bureau of Energy Efficiency. This is also required. And capacity building workshop for the certified energy auditors. See, what was identified was that a lack of awareness. It's not that the industries don't want to use industrial process heat, but there is lack of awareness. As a matter of fact, even the energy auditors or the certified energy managers, they had limited knowledge. So I think the capacity building workshops need to be taken up. And you know, as an industry body for 7.5 years, we operated the National Solar Energy Helpline. It did help a lot in resolving the query of the end users and was greatly influential in the market expansion. We still recommend its continuation. So there are about 500 plants worldwide for SHIP, and as a result now, the Solar Thermal Federation of India is currently executing a 3-year project with the German Solar Industry Association called as Solar Payback, which has an objective to increase awareness of the technical and economic potential of the solar heat for industrial process, increase willingness to invest and to promote this promising technology. So 4 countries are signatory: Brazil, India, Mexico and South Africa. India would be the lead country considering its progress compared to the other 3 countries, because we have already undertaken several projects and perhaps there will be a lot of learning curves out of it. Break the vicious circle of small deployment rates. You all can visit www.solar-payback.com. This is as a part of the International Climate Initiative funded by the Federal Ministry of Environment, Nature Conservation, Building and Nuclear Safety. Who are the partners? Our partners are the Indo-German Chambers, then the Brazilian Solar Thermal Association, the South African Solar Thermal Association and the Mexican Solar Industry Association. More details about Solar Payback you can get at, as I said, www.solar-payback.com. Also, there is one website we are maintaining about the solar industrial process heat, which is www.cshindia. CSH stands for concentrated solar heat. cshindia.in. Here we have developed a number of knowledge documents about the technologies, about the installations that have happened. There are a number of videos you can see of the various applications. Thank you very much.
Thank you very much for providing also the industries the federation perspective and initiatives which are there, and reflecting also on creating a demand to really go to scale of 25,000 or 100,000 square meters. I know we are running a little bit late, but we also started late, so I don't want to cut the session completely short and maybe open up for one or two short questions, if there are any questions from the audience. To any of the speakers. So, the gentleman here on the front row.
Thank you, Chairman. I am H. Kumar from CSTV for Energy Access, Promotion of Solar Technology in India. I am also a life member of Solar Energy Society of India. Thank you very much for your exposition of the UNIDO activities in India on the solar promotion. Heartily thank you very much. My point is main power development. We have the main power to operate all this system in India. I belong to Rajasthan. Rajasthan highest solar radiation, but we are the main power. So what is the role of how the UNIDO can help in the main power development and capacity building?
Yes, that's a big question to be asked. I think that UNIDO is the basically the industrial development organization. So we are more focused on the renewable energy applications in industry. So more the, if you want to say, the demand side management. So trying to reduce the demand of industry on the grid. And not so much immediately working with the utility companies and the sort of the main power grid, which is more the work of the International Energy Agency and other agencies which are more working on that area. I think notwithstanding that, saying that, oh no, it's not our cup of tea, I think that we are still also looking at innovations that can be promoted for inclusion also in the main power grid. But the main power grid, power utility industries is not really the mandate of UNIDO, but we would like to help out where we can see things fit and find smart solutions for operating of the grid as well. And there are many efforts underway, as you're undoubtedly aware, of how can we operate a grid with basically 40% PV. What's the sort of the commitment under the Paris Agreement? So I think I should leave it there. I would like to open up for one more question, if there is anybody. I've scared off everyone. Okay, then I think we come to the end of this session. I think it was interesting to hear from the different perspectives that on one hand it is very clear that solar thermal applications for industry are mature, they can be applied in different, there are still maybe some teething problems and issues to further optimize and further improve and innovate in this, but there's no way to say, oh, this is only in the backyard proven. This is a proven and established technology that, as any technology, has to evolve further. And we should really focus on creating a demand and facilitating then also applications, so that maybe some of the element of risk in terms of technology and risk in terms of finance can be mitigated, so that there's less risk coming to the proponent for this. And that, I think, is mainly a capacity building initiative where UNIDO can play a role, where MNRE can play a role, in addition to the, of course, the suppliers of the systems that should come forward. But I think it's also fair to say that, of course, the potential buyers would like to see also some impartiality and some independent observations in addition to getting specific quotations for technologies. So with that, I would really like to thank this panel speakers for this afternoon, and thank you very much for your participation. Thank you.
I would like to thank all the speakers and Honorable Chairperson, sir, for taking the meeting so fluently and for the information on solar heating. So without further ado, I would request Mr. Van Berkel to give token of appreciations to all our speakers. I would start with Mr. Niranjan Desai, Vice President, Business Development, Orb Energy. Moving on to Mr. Aravindh, Scientist B, Solar Thermal CST Division, India. Mr. Jaideep Malaviya, Secretary General, Solar Thermal Federation, India. Mr. Madhusadhan Rao, Managing Director, Oorja Energy. And finally, I would request Pallavi from the Exhibition India Group to give a token of our appreciation to Mr. Rene Van Berkel.